Hi, this is David Voss, CCIE 11372. And in this video, you're going to receive an overview of WAN design. We're going to cover some of the basics of wide area networking so that you can properly lay a foundation for the topics that come up after this video, so you can understand what specific WAN technologies are out there and where they fit within the enterprise campus. WAN technologies operate at the enterprise edge in the modular Cisco enterprise infrastructure. WANs span across large geographical distances in order to provide connectivity for various parts of the network infrastructure. Unlike the LAN environment, some WAN components are not owned by the specific enterprise. Instead, WAN equipment or connectivity can be rented or leased from service providers. Most service providers are well trained in supporting not only traditional data traffic, but also voice and video services. In addition, unlike LANs, WANs typically have an initial fixed cost and thereafter periodic recurring fees for services, which is one reason you never want to over-provision your wide area network, because it's money down the drain. This cost and fee structure requires implementing effective quality of service mechanisms in order to avoid buying additional WAN bandwidth when it's not necessary. WAN technologies design requirements are typically derived from the following: application type, application availability, application reliability, the costs associated with a particular WAN technology, and usage levels for the application. All of these will dictate what type of WAN technology you're going to want to use. The enterprise edge represents a large block, or it could be several blocks of equipment. This large module is typically split into smaller blocks, each with a specialized functionality. Here are the following components you will find in an enterprise: the WAN block for branch offices and remote access connectivity, the e-commerce block, which is a part of the organization and obviously serves the business, customer-facing business applications, the internet connectivity block, which offers robust internet access with some level of availability and redundancy, and also you'll find within this block often your DMZ services. And then the remote access or VPN block, which provides secure connectivity for a large number of employees who work out of a home office. An important topic when considering CCDA certification is the common categories within various WAN technologies. An essential concept is circuit switched technology. The most relevant example of this is the PSTN, or Public Switched Telephone Network. One of the technologies that falls under this category is ISDN. The way circuit switched WAN connections function is by being established when needed and terminated when they are no longer required. Another example that reflects the circuit switching behaviors is the old-fashioned dial-up connection. You may remember, or maybe you don't, using a dial-up modem analog access over the PSTN to access the internet in the late 1990s. The opposite of circuit switched option is the leased line technology. This is a fully dedicated connection that is permanently up and owned by the company. Examples of leased lines include TDM, or time division multiplexing based leased lines. And these are usually very expensive because a single customer has full use of the offered connectivity, and you're paying for that bandwidth whether you're using it or not. Another popular category of wide area networking technology involves packet switched concepts. In a packet switched infrastructure, shared bandwidth utilizes virtual circuits. The customer can create a virtual path, which is similar to a leased line, through the service provider's infrastructure cloud. This virtual circuit has a dedicated bandwidth, even though technically it's not a real leased line. Frame relay is an example of this type of technology. Some legacy WAN technologies you may have heard of, such as X25. That's the predecessor of frame relay. An example of cell switch technology is asynchronous transfer mode, or ATM. This operates by using fixed-sized cells. Cell switch technologies form a shared bandwidth environment from the service provider standpoint that can guarantee customers some level of bandwidth through their infrastructure. Broadband is another hugely growing category for wide area networking, and this includes technologies such as DSL cable and wireless. Broadband involves making a connection such as an old-fashioned coax cable that carries TV signals and figuring out how to use the different aspects of that bandwidth. For example, by using multiplexing, an additional data signal could be transmitted along with the original TV signals. And obviously, wireless continues to expand at a rapid pace. As detailed so far, there are many options when discussing WAN categories. All of these technologies can support the needs of modern networks that operate under the 80-20 rule. That is, 80% of the network traffic uses some kind of WAN technology to access remote resources. Next, let's talk about WAN topologies. There are three you should know of. First, let's talk about full mesh topologies, which for obvious reasons require a large number of nodes and added extra overhead, referring back to the formula n times n-1 divided by 2, where n denotes the nodes. This obviously can get very expensive very fast. That being said, the full mesh topology is the best option when considering availability and reliability. Failover will occur on the other links and devices, assuming you have your routing protocols programmed correctly. The downside of full mesh topology, obviously, is the extra overhead associated with building and maintaining all of the connections and the high costs required to install all of the links. A more popular design is the hub and spoke topology. The hub router is usually located at the headquarters location and connects to branch office routers in a hub and spoke fashion. The hub and spoke topology is not the best topology as far as redundancy and availability are concerned, as the hub device is the most common point of failure. So obviously in the hub area, you're going to want to have redundant systems with redundant power supplies, redundant route processors, etc., etc. Hub and spoke topologies are obviously less complex and less expensive than full mesh topologies, so the added investment in the hub site is well worth it. Next, there's partial mesh. This involves a combination of full mesh and hub and spoke. The partial mesh topology falls in the middle of full mesh and hub and spoke topologies in terms of availability and costs. This topology is useful when a high level of availability and redundancy is required only in some areas.
So it's a good time to begin discussing network architecture types. The first network architecture type is point-to-point. Now this is rather self-explanatory. As you can see, we have two network devices connected by a single network link. The typical point-to-point connection is a serial link. The next architecture type is broadcast network. A broadcast is sent from one of the routers and then propagated to all other routers on that segment. Ethernet networks, like the one you see below, are common examples of a broadcast network. The next architecture type is NBMA, or non-broadcast multi-access. As the name implies, it does not support broadcasts. Therefore, when an interface on a router needs to send out data to all other routers, it must send individual messages to each router. NBMA also doesn't support multicast.
So here's what you've learned. You've learned about the basics of WAN topologies and wide area network types. All of these things will help you in laying this foundation you need as you begin to learn about how to design for wide area networks. Laying a foundation for the terminology that you'll need to understand, such as hub and spoke, full mesh. But also, as you begin to design wide area networks, or you're asked questions about wide area networks in the CCDA exam, this information is going to be in any question you would receive, because they're going to assume you understand the topics that are covered in this video very well. Good luck in your studies.